Next up, we have two speakers from Net Insight. They're going to speak to us about redefining media delivery, integrating a stream transformation engine in the distribution pipeline for next-gen streaming efficiency. So we're going to hear from Pierre Lefebvre and Adam Nielsen. Pierre is a software engineer at Net Insight, specializing in cloud-native broadcasting solutions and latency-sensitive live video transcoding. And Adam is a product manager at Net Insight, focusing on cloud-based platforms and next-generation products. Give them a hand as they make their way up.
Thank you. Yeah, I think we went for the title for the longest title, win that award. I'm not sure we will win, but we did our best. Nice seeing you all here. As I said, we're with Net Insight, and we're here today to talk a little bit about how we see the future when it comes to being efficient with compute, using both cloud and on-prem technologies, something we've been investigating for a long time now, and something that we see, as this industry is evolving, and everyone here speaks about it. It's moving so fast. A lot of people in here has a bunch of experience. I started 11 years ago as a producer at Eurosport in Sweden. At that time, we had a very small scale business. We did, events we literally did rock, paper, scissors. I'm not sure if you've ever seen that live, but it's like the most ridiculous thing you can ever see, because when you hear someone being a pundit trying to explain who's the favorite in rock, paper, scissors in live sports, it's like the most ridiculous thing. But at that time, that was something we did. And now you can stream anything from everywhere at any type of quality. But that also means that we need to adjust the business and how we do things and leverage the technology that is out there. So we're going to talk a little bit about that today. Do I have the chair? Oh yeah. Nice. Thank you. So if we look at what has been done previously using sort of the cloud and doing transcode in the cloud, is that one problem we've always seen is that it became a centralized bottleneck. Basically, you put a bunch of stuff into the cloud in a centralized way, and that becomes a huge cost. It is an exponential growth where a single stream costs something in between $200, $400, $500 per month for a 10 megabit stream, HVC or AVC. And that's difficult, right? Because you want to scale your industry, and we all know that there's so many streams going to so many places. The cost becomes an issue, scaling becomes an issue, the operations become a nightmare because you need to keep track of this, and it's just not feasible. And that's the way it started, and we're trying to move away from that and find a better way of doing it. And there are multiple different ways of doing that. But as the market now is evolving, we know that the scaling is something that puts pressure on the industry. A live event has multiple endpoints. It doesn't matter if you do a rock, paper, scissors event or the Olympics. We're going to send that content to a bunch of different places, either locally or globally, and we need to adjust to whomever the taker is. Maybe you're sending something to an end user on a cell phone. Maybe you send it out to, a broadcasting facility all over there. Every taker is going to need their own rendition. Someone wants HVC, someone wants, AVC, someone wants 480i, someone wants 1080p. We need to create a different rendition for every single taker. And when you try to build this type of solution, having a stream coming in and multiple streams going out, each new stream becomes a linear growth in cost. And the example we have here is from AWS Media Live. It's a median cost for an AVC, HVC on-demand cost for a stream. And if you look at doing that 10 streams over a 3-year period, you will pay $100,000, which means that stream, a single stream, will cost you $10,000 for 3 years. It's not working. It's not a way of doing it. Those costs, in the end, becomes unsustainable for a business. And we need to have a different approach as the business is growing. The codec demands changes. We have different types of resolutions out there, different types of bit rates. And that's what Pierre here is going to explain, how we foresee that happening and how that can be done, and how we look and think we can solve this solution in the way that we do things.
Yeah, thanks for that great intro, Adam. So, traditionally, like you said, one might ingest video somewhere and then send it up to the cloud for transcoding and then send it out to all the different takers. But this kind of relies that both the ingress and the egress have a good connection up to the cloud. And I think for us, a real eye-opener was a case in Latin America where both the TV station and the takers had really, really low bandwidth, like really bad connections. And so we had to think, where can we do this transformation? Of course, on the edge. You can either transform it on the input side or on the output side, just using a traditional encoder or like a transcoding box. But that kind of loses the orchestration of cloud video delivery that we all enjoy. So we started thinking about how can we put the flexibility of transcoding on cloud, where you can spin up a transcode, just choose your parameters and everything's working. How can we combine that with the flexibility of actually having hardware on the ground, and sort of integrating it in the pipeline? And so our solution is a hardware agnostic transformation engine that can actually be ran on lots of different hardware, and taking advantage of that and making it available to this cloud orchestration layer, where we can actually transcode in different locations in the pipeline. So for example, here you can see like the traditional pipeline going through the cloud, or like a more point-to-point routing where you go directly ingress to egress. But you still have the same operational efficiency of just specifying what output format you want, and then letting the hardware take care of it. This is enabled, like Shiri mentioned before, but the great ARQ protocols, both RIST and SRT, which allows us to not really have to worry about the links in between, only just connecting it and then doing the work on either end. But so this perhaps sounds a bit like magic, like drop-in black box that just does all the transcoding, but it really isn't. And we've been able to make it thanks to all of the great open source projects and standards out there, like the great ones introduced here at SMT. But so primarily we use a Kubernetes orchestration layer, and a control plane that actually sort of manages everything top down, where we only have to send configuration out to the edge nodes. So the actual orchestration is not taking the bandwidth away from the precious video bandwidth that some edge devices might have out in the forest somewhere. And then going up, obviously we have the stream transport functions, which is using the great standards like RIST and SRT. And of course, we need to rely heavily on stream analysis functions to make sure that the pipeline is working well. But then the interesting parts are here on the right, where we have transformation functions, which are enabled by different hardware accelerators that we have built support for and pass through Kubernetes and Docker, which means that you can actually drop this engine anywhere, and it just adopts to whatever hardware you have installed in the machine. And so really taking advantage of CPU transcoding for maximum compatibility, or the latest and greatest GPU transcoding and VPU products. And doing this offers a great optimization potential. Because traditionally when you have, for example, 200 different takers, a lot of them are probably going to want almost the same format, but a slight difference. So for example, if your input format is interlaced, you're going to do some kind of deinterlacing if you want to output it in a progressive output. But probably you're going to do that multiple times because you might want a 720p, 1080p, different frame rates perhaps. But doing all of this transcoding in a sort of orchestrated way means that we can actually optimize away doing certain operations twice. So in this specific pipeline, you can notice it's maybe a bit small, but the two top pipelines are both deinterlacing and then encoding. And so the bottom one, we only deinterlace once and then encode it twice into the formats required. And so since you kind of can control top down all of the pipeline from the input all the way to the output, it's possible to co-locate the functions in a point that makes sense on the path from input through some cloud region to the output point. Yeah, back to you.
Yeah. So when we looked at this and the cost was how do we compare what you do in the cloud compared to what you do on Edge and COTS? And on the top, you have the OpEx cost, which is the on-demand AWS live media service. And what we're trying to do here is to have an AVC stream at 10 megabits being transformed into an HVC 10 megabit stream. And underneath, you have the same stream, the exact time of configuration being done using a server running a VPU, so a video processing unit, which is dedicated for those type of codec conversions, and doing a sort of a normalized cost comparison so that you can actually see the difference. And, if you take a server, which costs roughly around $3,500, so we did this in our lab, you can find a VPU starting at $1,500, and you take that cost and you add to your operational cost for that, the service cost for that for 3 years, with the same amount of streams, you can definitely see that there's a huge difference in that cost when you do it on Edge and COTS compared to doing it in cloud. You can save a bunch of money. I think if you run this down to a monthly cost, which we know that most customers want to have that, right? People want to understand, what do I pay monthly for one of these things? I think the cloud cost is around $250 or $270, whereas running it on Edge and COTS in this case is roughly around $97. So already there, you will see a huge cost difference, and it can make sense because if you have streams that are going to run 24/7 for 365 days a year, you can fix that cost at a much lesser rate than running it through cloud. Even if you run it on demand, which is, the lowest cost, you can reserve it as well, which is even more expensive. It just makes more sense trying to move that into an environment which you can control, which is running on-prem. And it also means that you can put it where and do these conversions where it makes most sense. So if you have one conversion that you want to do and send out to 100 takers, you probably want to do that as quickly as possible, right? You want to do that on the input side. Save yourself latency and do that as quickly as possible and send the same thing out to the outputs. But if you have one stream that you want to convert to 10 different renditions, you will do it at the outputs instead. Send one iteration of it and do it as close to the taker as possible. Save yourself bandwidth, save yourself cost, save yourself latency. So if you take this way of thinking and use the sort of transformation engine idea and what we've put in place, you can actually save yourself a bunch of issues, cost, and operational, problematic issues, because it is tough. Like, we have to do all these things all the time. It's live. It's very hard to plan for it. But if you have linear feeds or other feeds, it can be done. And the budget you save by doing this, you can put into a bunch of other things, right? You can put it into even more power. You can put it into rack-based or operations, wherever it is. And you will still, in the end, come out ahead than using the cloud on demand. So that doesn't mean, of course, that, on-prem or COTS or Edge always wins compared to doing it in the cloud. They're different use cases, and they both make sense in different ways, right? The cloud, as most here know, or everyone knows, it gives you a great way of using it quick, right? It's available. You can go out there. You can spin it up in no time at all. It has the agile ways of doing things, elastic scaling. You can use it, for trials, for pop-up events. Maybe you get some information today that you have an event this weekend that you need to get up and running. You can use the cloud. It's there. It's very easy to spin it up. If you have knowledge, it can get it done. But if you know that you have 24/7 streams that you're going to run, there's a high fan out, this is going to be there for a long, long time, then it probably makes sense to take a look at sort of, can we do this on Edge or COTS? Because that can save you cost. Because running things 24/7 in the cloud will cost you a bunch of money. Even if you have these great deals with your cloud providers, in the end, it is hard to justify what's going to happen, because you get these 3 years deal. They're going to give you a great discount. And then when those 3 years are over, that's when they're going to get you, because you're stuck. So there isn't one winner, of course. The hybrid approach is in the end the best. of what you can do, using both the cloud and edge COTS when it matters is how you leverage it. It always is, right? It's not either or. It's, picking the right opportunities, the right times to use whatever makes the most sense. And that takes time to figure out, but also to think about it in the way you can operate it. I think what Pierre sort of, pushed to is like having a portable design that you can put either on-prem or in the cloud. That's what's important. So you don't have to change how you operate things, because in the end, you don't really want to care that much about what's happening underneath. As long as your operators and what you do on a daily basis looks the same and acts the same, that's what you want to achieve. And I think that's sort of the big part of what we try to design, is to make it portable. You must have that, because if you have to adjust the way you work because of where you run stuff, that's going to be very problematic for anyone who's trying to use your solutions. So if you look at sort of, thinking about how would you do this in practice, I would probably suggest that you could start in cloud just to validate what you're trying to do. If you're just doing transport and then you want to maybe do some more transformations, do some code conversions or something, you can try it in cloud, validate it there. There are a bunch of opportunities. Compute is always available, almost always available, but at hard times it's going to cost you more. But cloud is a perfect way to start. Get some knowledge, understand how it works, see what it can do for your customers, see how you can get value out of it. It's the easiest way. Instead of doing a CapEx investment in a bunch of GPUs and servers and all of that and send it out and don't know how much you're going to leverage in the end, use the cloud. It's the best way of validating what you're trying to achieve from the start. Then, of course, you start looking into the hybrid part. Try to scale up. Maybe you see, we have these 24/7 events. Let's try to purchase some GPUs, VPUs, whatever it is, put it out there in a server and run that, because you've already validated it. You know that it's working. So now you can actually do that investment to put it out there, because I'm going to run this service for 3 years. It's going to be there. We got the contract. Everything's up and running. It's going to be safe. We're not going to be able to do so many changes. It's a perfect way to go. And then by the end, when you're really, really there, you will get the edge and COTS part to optimize your whole workflow, right? Because then you have your whole network. You know your topology. You know what you're running when. And in the end, you will have that knowledge about how you do that. All the way you have the portable design. So from an operational point of view, no one is going to know whether or not, it's not going to look different because you're running it in the cloud or somewhere on the edge. It's going to look the exact same way. But you scale it and you take it step by step. Because we've seen a lot of, people trying to do it all at the exact same time, and that never works out. A lot of people scale up way too fast because they have this huge contract they already signed and they need to do it. It's small steps. It's a small step approach, because otherwise your investment is going to turn out to be an awful thing, and you're going to have to solve that on the fly, which is very, very stressful, and it will cost you in the end. So it needs to be very careful. You need to be very careful when taking these steps. If we look at sort of the key takeaways, which we've talked about, hybrid wins. It's mostly us in all the cases when we talk about this industry. It's very hard to have a one-track thing and say, this is the way to do it, no matter what you're trying to do. You want different types of vendors. You want different types of providers. We're also big risk proponents, but if customers want to use other ARQ transport protocols, great. You can do that as well. Have an environment that's as agnostic as you possibly can, because you never know what's going to happen tomorrow. A company might get acquired and all of a sudden you lose all of your services or something like that, or you don't get access to what you've had before. Have a cost framework. Like, start really thinking about what you pay for and how you pay for it, right? If you go to a cloud provider, you will get these cost comparisons and all of that, and they will tell you, this is great, it's going to cost you this, sign this contract for X amount of years, we're going to give you this. But compare that to what you can actually do by running things on COTS or on the edge, because, and try to normalize that so you can do it over a period of time. Because in the end, we all want to figure out what's the monthly cost. Like, 3 years is a long time, but in the end, we care about what we pay. It's easier to see numbers when we have it on a monthly basis. And it's easier for us to talk to our customers when we tell them, this is what you're going to pay for a specific service on a monthly basis, right? You have a channel, it's 24/7. This is what we're going to charge you for it. Because if you say it's 36 months, it's a long amount of time. the number looks huge, and as soon as someone sees a huge number, they're going to question everything. It's easier to try to get it down to a monthly basis. So try to get that normalized when comparing these things. And then build your solutions and architecture and operations for portability. It's clear we sit here today, and then tomorrow there's something new coming along, right? A couple of months ago, I was highly unaware of the MXL stuff that all of a sudden showed up, and now it's here, and it's in RFIs, and everyone's supposed to, have it in. It's like, okay, cool. We'll have to adjust to that. We never know what's going to show up tomorrow. And trying to build for sort of portability and flexibility is key in order to keep your business running and your operations up and running as quickly as possible. It's difficult, but it is something you can achieve by using really good open source protocols and other things out there, right? There's a reason why we're trying to go in that direction. NetInsight started as a proprietary company, and we realized that's not the way to do things. We need to work with others because that's just the way it is. No one is buying everything from a single company. We need to work together. We all also need to work together on how we can build the most efficient solutions as possible. So when you build your networks and your solutions, build them having portability in mind, using things that can actually be compatible with other solutions. Yeah. I think that was it. Any questions?
We have a couple of questions. Start with a slightly more existential one. So, how do you secure this infrastructure is the first question we had.
In what way? You mean the streams themselves, or? Yeah. I mean, you can use existing like encryption for streams. I think both SRT and WIST supports that. But then in general, it's just best practices, making sure that everything is encrypted in transit, and that you only we have like whenever you register an appliance, we do a key exchange and make sure that it's actually supposed to be there. In general, just following best practices, I'd say, both for software engineering and for broadcasting.
Okay. And can you provide reporting on the utilization and capacity of the COTS or cloud elements being used?
Sorry, what's that?
Can you provide reporting on the utilization or capacity of the COTS or cloud elements being used?
Yeah, exactly. Yeah, so that's actually a great, a huge problem. And I think there's no perfect solution for that. Because every encoder has a slightly different performance capacity, and they all have different capabilities. So we take a lot of care, and whenever you register an appliance, to make sure that we report and sniff out all of the capabilities, and then try to make it as easy as possible to link what transformation functions you're trying to use to what the accelerator actually supports. But then CPU libraries usually have support for all of the features as a fallback.
Any more questions in the room? No? All right. Thank you very much, guys.
Thank you.